Alright, welcome to our first lecture for algebra. We're starting on page 76 in your textbook. The first thing we're going to do is go over some vocabulary terms here. We have an algebraic term, is our first one. An algebraic term is a collection of numbers, letters, exponents, symbols. So the examples in the book, they've got a -6p, 5xy, -8n squared, n, and 2 times x plus 3. Now the first one we have on the list is 3. When I have a number all by itself, it's called the constant. Whenever I have a letter that I don't know what it is, then it's called a variable. So the p is a variable, the xy, they're both variables, n squared is a variable, and then the x over here, those are all variables. We have the term the coefficient. The coefficient means the number in front of my variables. So the 5 would be a coefficient, the -8 would be a coefficient. What would the coefficient be for the n? 1. Okay, so that's really a 1n. So the coefficient is a 1. The coefficient is the number that's attached to my letters or variables. So when we talk about algebraic expressions, you can have something like 2x plus 4y equals z. That's an algebraic expression. Or 2 times x plus 2 minus 1 equals 10. Those are both examples of algebraic expressions. So what we're going to start on is learning how to take word problems and translate them into math. Down at the bottom where it says example 2, the first one they give us is twice a number increased by 5. How would we turn that into an equation? Bottom of page 76, example 2. It says translate phrases into algebraic expressions.
A number plus itself. Okay,
so twice a number. I can write that as 2x or 2n or 2x or 2y or 2r or whatever. Okay. 2 times a number that's unknown.
Plus 5.
Plus 5. So increased means addition. What are some other words that might mean addition? Can we think of any?
2 negatives.
If I have 2 negatives, yes, I will add those together, but can you think of some other adjectives where I would add? So more than, in addition to, increased by.
I'm terrible at crosswords.
Those would all be examples of when I would add. Okay, so our second example is 6 less than 3 times the width.
3 times x.
Okay, so 3 times the width, then what?
-6.
-6. Okay, any other descriptive phrases you can think of where it would be subtraction?
Less than, taken away from.
Decreased by. Okay, there's some good. Okay. Example C is 10 less than triple the payment. How do I triple a number? What do I do to it?
It's the same as 3 times.
Okay, 3 times a number, and 10 less minus 10. Okay, our fourth example is 250 feet more than double the length.
Double the length. How do you write that?
Double the length, so 2 times the length
Plus 250.
plus 250. So example 3, create a mathematical model. The cost for a rental car is $35 plus 15 cents per mile. So express that in a formula. How do we do that? So cost for the car is equal to what?
15 times x.
So I'll
Plus
have,
0.15.
okay, why 0.15 and not 15?
Because it's cents.
Okay, cents. So 15 cents times x is going to equal our number of miles. And what else is in there?
Plus 35.
Plus 35. So let's say I drove 50 miles. How would I solve that?
0.15 times 50.
Okay, whenever I have a variable, I need to draw in a set of brackets.
And then you have it there.
And I add in my number. So calculator, what's 0.15 times 50?
7.5.
7.5. So cost is 7.5 plus 35, which equals
42.5.
42.5. Translate that into dollars. $42.50 to rent my car and go 50 miles.
Now how do we figure? How do we figure out how much it costs per mile?
Remember it said it costs 15 cents a mile.
And I'm just on an average. This is a sidetrack, but now if we want to figure out what it actually costs per mile.
To drive the car?
Yeah, it costs $42.50 to rent the car to drive 50 miles.
Okay. $42.50 is what I paid, and I drove 50 miles. So how do I do that? What should I do?
Alright, that's it.
What's my cost per mile then? So 50 goes into 42 0 times. About into 425. 8. And then 250.
So 85 cents a mile.
85 cents a mile. Okay. There are a couple of these in the homework where you turn a story type of problem into an equation, so we can review those again if we need to. Evaluating algebraic expressions.